So now we're on to part 2 of 4.6. So what part 2 is essentially we're going to have to use all of our exponent laws that we have learned and learn how to simplify expressions using these things. Okay, so it's kind of a puzzle. Lots of the times there's multiple ways to do something. It's just which is the most efficient way. And that comes with practice learning how to do that. So let's look at A here. So for A, how would I go about simplifying this? Well, to simplify, first I'm going to note that I have two similar bases. Okay, I have two things being that have an exponent, but they're both 0.8. So this, I'm going to use my add exponent law. Okay, so what I'm going to do is I'm going to do 0.8 squared times 0.8 to the power of -7. I'm going to combine that into a single base, so 0.8, and I'm now going to add their exponents. Okay, and when I add their exponents, I get 2 plus -7, which gives me 0.8 to the power of -5. Now remember, we often don't really like having negative values, okay? So I could even go further and apply my negative exponent law. So that I have a negative exponent, I'm going to apply the reciprocal. So here I could make it 1 over 0.8 to the power of 5. Okay, and I could technically leave it like that. I could plug in my calculator, but at the end of the day, it just wants me to simplify. Something else I could do here is I could understand that 0.8 equals 4 over 5. Okay, so if I understand that, I can represent 0.8 with a fraction. So why don't I do 4 over 5 to the power of -5? And then from here, I can apply more rules. If I have a negative exponent applying to a quotient, I can take the reciprocal of that quotient and make it a positive power. So A over B, I flip it. So why don't we flip this and becomes 5 over 4 to the power of +5. And then from there, we can apply even another rule where if I have a quotient, I can apply my powers to both the numerator and the denominator. So here this becomes 5 to the power of 5 over 4 to the power of 5. Okay, and we could plug these in our calculators and maybe see what they are and see if my two expressions equal each other. So let's maybe figure out what 1 divided by 0.8, let's put brackets, 0.8 to the power of 5 is. So that gives me a number of 3.05 ... Okay, so an irrational number. Now let's figure out, actually that wouldn't be an irrational number. There is a pattern going on there. Anyways, here let's do 5 to the power of 5. That gives me 3,125. And let's do 4 to the power of 5. So my bottom number here is 1,024. So there's a fraction. Let's do 3,125 divided by 1,024. Well, would you look at that? That gives me the exact same solution. Okay. And of course, because again, these are the same things. Okay, they're just expressed differently. Okay. Let's move on to B here. So there's lots going on in B. Now, in order to go about B, what we have to do is we have to apply quite a few different exponent laws. So again, it's a bit of a puzzle. First, figure out what you want to do. Here I have a quotient with that has a power to the power. So the first thing I can do easily to both of these is apply my power of a power law. So I have a base that has two exponents, so I multiply the exponents. So here, I'm going to combine these exponents and multiply. So this will become -4 over 5 to the power of 2 times -3, dividing -4 over 5 to the power of 4 times -5. And then let's simplify these things. So 2 times -3, that will give me -4 over 5 to the power of -6, dividing, and then I have -4 over 5, and here I will get 4 times -5, which gives me -20. Now from here, what should I do next? Well, I have negative exponents. Again, we don't really like negative exponents, so let's make those positive. Both of these I have quotients. So the fact I have quotients in both of them, I am going to just simply take the reciprocal and flip my fractions, okay, to make that a positive exponent. So this will become negative 5 over 4 to the power of positive 6 dividing negative 5 over 4 to the power of positive 20. Okay, now what should be my next step here? My next step is I'm going to actually bring in my exponents to each value. Okay, so that is my rule right here. So I have a quotient with a single power. I can bring that power in to both of my denominator and numerator. So that's what my next step is going to be. My first thing is I'm going to apply the power of 6 to negative 5 and positive 4. And remember that this negative can either be applied to the 5 or the 4. So what I'm going to do is apply it to my numerator. So this will be negative 5 to the power of 6 over 4 to the power of 6. And this thing's dividing negative 5 to the power of 20 over 4 to the power of 20. Okay, so recognize what I've done there. I've applied the exponent to both things. Now, what should be my next step here? So recognize I am dividing, okay? If I'm dividing fractions, right? If you divide two numbers, you can subtract their exponents. Now, it's really important to understand here is that might work for this case, okay? Another thing to remember, and this is something you learned way back when, that if you're dividing a fraction, so let's say 3 over 2, what you can do is you can multiply by the reciprocal. So this is something you would have learned way back when, maybe even in junior high. So I can multiply by the reciprocal. So here I flip the thing I'm dividing. So that's what I'm going to do here. To get this to turn into a multiplication symbol, I'm simply going to flip. So my front is going to stay the same. So that's negative 5 to the power of 6 over 6. And I'm going to now do multiply 4 to the power of 20 over negative 5 to the power of 20. Okay, and why is that useful? This is useful because now you can apply another law. Here, I just get negative 5 to the power of 6 times 4 to the power of 20. So I can simply represent that as 4 to the power of 20 multiply negative 5 to the power of 6 over, and here I can represent my denominator as 4 to the power of 6 times negative 5 to the power of 20. So this will be 4 to the power of 6 times negative 5 to the power of 20. And now recognize we have one more exponent law that I can do. I'm dividing similar bases, so in this case 4 and 4 and negative 5 and 5. What do you do when you divide similar bases? You subtract their exponents. So what I'm going to do is I'm going to subtract my exponents here. So focusing on my 4 and 4, it's 20 minus 6. So this will become 4 to the power of 20 minus 6. Here will become negative 5 to the power of 6 minus 20. And from there, 20 minus 6, well, that gives me 4 to the power of 14, multiplied by negative 5 to the power of negative 14, right? 6 minus 20 is negative 14. And the last thing here, I have a negative exponent, so I'm going to make that positive by putting it in the denominator's position. So this will be negative 5 to the power of positive 14. And I would leave it like that, okay? Because at the moment it just wants us to simplify. That's pretty simplified in my opinion. Okay, so lots going on there. Again, this last section is definitely the most difficult, but it just takes lots of practice to learn how to do it and organize your work. Let's move on to C. So C is a little bit more, maybe not easier is the right term, but it is definitely a little bit more workable. So here, I have 1.5 to the power of negative 3 to the power of negative 5, dividing 1.5 to the power of 5. What should I do here? Well, the first thing I'm going to do is I want to get this into a single exponent. That is my power of a power. So if you have a power to the power, you multiply them. So here, I'm going to get 1.5 to the power of negative 3 times negative 5 over 1.5 to the power of 5. From here, negative 3 times negative 5, well, that leaves me with positive 15 over 1.5 to the power of 5. Now what should my next step be? Well, my next step, here I have two similar bases, and when you have two similar bases dividing, you subtract their exponents. So here I'm going to subtract my numerator's exponent by my denominators, so 15 minus 5, and I'm left with 1.5 to the power of 10. And there's my simplified solution. So this thing equals 1.5 to the power of 10. Okay, let's move on to D here. Okay, maybe I'll switch my colored pen. Now, remember, variables just act as numbers. Again, these are similar bases, x and x, and then you have one more x, okay? Recognize that this has no exponent. What happens when there's no exponent there? You can imagine a 1 there, okay? So what's the first thing I'm going to do here to simplify? What would you do? So maybe think about what you would do for a second. So if maybe you said, take this exponent and subtract this exponent. That's not wrong, you could do that. Personally, I want to get my numerator as a single exponent, or a single base. So why not use our multiplication where we have similar bases multiplying? So let's add their exponents. So here, this would become x to the power of negative 3 plus 1 over x to the power of 5. And then from there, we can simplify. Negative 3 plus 1 gives me x to the power of negative 2 over x to the power of 5. And now we have two bases dividing each other. So what happens when you have two similar bases dividing each other with exponents? Well, you take their exponents and you subtract. So I'm going to use the subtract exponents law. So here, this becomes x to the power of negative 2, subtract 5, and I'm left with x to the power of negative 7. Now again, negative exponents usually doesn't fly. It's good math etiquette to make these positive. So I'm going to take my reciprocal. So negative exponents, if you have a negative exponent, you take the reciprocal and your exponent becomes positive. So what I'm going to do here is I'm going to take x to the power of negative 7 and make it x to the power of positive 7. And there's my simplified solution of my above expression. So this can be actually represented as this. Okay, so I would suggest really maybe pausing the video and trying a few questions on your own. But let's move on to maybe 3 more examples. So again, these examples can be very, very tough. Let's simplify the following expressions. So here, we have a bunch of variables multiplying each other. We have numbers multiplying each other and all these types of things. So we might have actually seen stuff in chapter 3 on how to deal with stuff like this. Now, in this case, everything's just multiplying each other. So remember, 4xy equals 4yx, which equals y4 times x. You can just manipulate these. Since it's multiplying, it's commutative. You can move them around. Here, everything's multiplying each other. So I'm going to put the numbers multiply each other. I'm going to put the variables multiplying each other and the same variable. So here I'm going to do 2 times 3, x cubed times x to the power of 6, z to the power of negative 3, z to the power of 3. Okay, and now from here, hopefully you can see what we're supposed to do. Of course, we just multiply our numbers together. So this 2 times 3 will give me 6. x to the power of 3 times x to the power of 3, well, that's a common base. So I'm going to add their exponents. So this will be x to the power of 3 plus 6. And this will become z to the power of negative 3 plus 3. Similar bases, multiplying, add their exponents. And we can simplify this even further. This can become x to the power of 3 plus 6. That is x to the power of 9. Z to the power of negative 3 plus 3. Well, negative 3 plus 3 equals 0. So this is z to the power of 0. Now, remember, what is any number to the power of 0? Okay, often people forget this. It's 1. Anytime you have any type of number, whether it's a billion, let's make it a million here, to the power of 0, that's just 1. So here, remember, this is just a placeholder for a number. So z to the power of 0, well, that just equals 1. So this will be 6x to the power of 9. So this thing actually equals 6x to the power of 9, which is a way easier expression to use than something like this. Okay, let's move on to b here. So b, how am I going to deal with this? Well, I have numbers dividing each other. I have similar bases with exponents, so I'm going to use a few rules here. First of all, 4 over 10, both of these things are divisible by 2. So that gives me 2 over 5. So I can represent 4 over 10 as 2 over 5. Now let's simplify x squared dividing x. These are similar bases dividing, so I'm going to subtract their exponents. And remember, since x doesn't have 1 in front, it's simply a 1 as an exponent. So this is x to the power of 2 minus 1. And then here, I have y to the power of negative 3 divide y to the power of 3. Well, I take my numerator's exponent and divide it by my denominator's exponent. So this will be y to the power of negative 3, subtract 3. And then from here, we can't do too much with our numbers any longer. 2 minus 1 gives me 1, so this will be x to the power of 1, or simply x. Y to the power of negative 3 minus 3, well, that gives me y to the power of negative 6. I can do one more thing here. Remember, negative exponents aren't super awesome. So let's make that a positive. How do I make it a positive? Well, I just put it in the numerator's position. So I can just put it in the denominator's position. So I've taken my y to the power of negative 6 and simply put it in my denominator. And now I have a positive exponent. And there's my simplified solution. So this thing equals 2x over 4y to the power of 6, which is, again, a much easier expression to utilize. Okay, let's do one more here. And this will be c. So in this case, we're going to have to apply a few different rules. Remember our rules where we have quotient and a power. You apply that power to the numerator and the denominator. Okay, so that's what I'm going to do here. So let's go 50 x to the power of 4, y to the power of 8, to the power of 1 over 2, over 2x squared y to the power of 6 to the power of 1 over 2. Now what do I do here? Well, something I'm going to do here is I'm going to apply this law. A times b to the power of m. Well, remember, if everything's just multiplying and there's an exponent, that exponent's going to be distributed and applied to every value in there. So I'm going to take my 1/2 exponent and apply it to each value. So this will become 50 to the power of 1 over 2, x to the power of 4 to the power of 1/2, y to the power of 8 to the power of 1/2, over, and then I'm going to do the same thing on the bottom here. So 2 to the power of 1/2, x squared to the power of 1/2, y to the power of 6 to the power of 1/2. So I've taken this 1/2 and made it the exponent of each value. Now I'm going to use my last law here, or my other law here, which is the power law, power to the power. So a to the power of n to the power of m, you multiply those exponents. So at the moment, I'm going to leave these two values. 50 to the power of 1/2 over 2 to the power of 1/2. Okay. Here, 4 times 1 over 2, that's equals x to the power of 2. So I'll maybe write that over here. 4 times 1 over 2 becomes 4 over 2, which is 2. Okay. 8 times 1 over 2, let's do that. 8 times 1 over 2, when you're multiplying a whole number by a fraction, you multiply the whole number on the top. So it'll be 8 times 1, which is 8. So that equals 8 divided by 2 is 4. So here I'll get y to the power of 4. Let's focus on our bottom here. So 2 times 1 over 2. That becomes 2 over 2, which is simply 1. So this leaves me with a single x on the bottom. And hopefully you can see here, 6 times 1 over 2. Well, that's 6 dividing 2, which is 3. So this will be y to the power of 3. Alrighty. Now we're left with just similar bases dividing. So here, again, I'm not going to do too much yet with these guys. 50 to the power of 1 over 2 over 2 to the power of 1 over 2. I have similar bases, so I then subtract their exponents since my bases are dividing. So this would be x to the power of 2 minus 1, because remember there's a 1 there. And then y to the power of 4 minus 3. And then we're left with 50 to the power of 1 over 2, 2 to the power of 1 over 2. 2 minus 1 is 1, so this leaves me with a single x. 4 minus 3 is 1, so this leaves me with a single y. If you really, really wanted to, you could put a 1 there, but it's not necessary. Now, what the heck should I do with 50 to the power of 1 over 2 and 2 to the power of 1 over, or 2 to the power of 1 over 2? Well, actually, recognize here that I'm going to apply this rule backwards. So I have the same exponent applying to two different numbers. So I can make this a single value to the power of n. So here I can represent this as 50 over 2 to the power of 1 over 2, and then this is multiplying x times y. Or my x and my y followed. Now remember, what does fractional exponents means? This is the index of my square root. So this is square root 50 dividing 2, and then my x and my y are on the outside, x times y. We're going to apply a radical rule. So if we go all the way up here, I have this rule where, well, actually we're going to take our numbers and divide. So 50 dividing 2, that gives me 25 x times y. And remember, if it's a 2 as your index, you don't actually have to put it because it's just a simple square root number. And finally, we actually know what the square root of 25 is. Because remember, 5 squared equals 25. So that means the square root of 25 equals 5. So here we'll get 5 times x, y. So believe it or not, this really ugly looking number or expression here can actually just be represented by 5xy, which is way easier to deal with. Okay, so that was definitely a lot to learn there. Okay, should you be expected to be able to do that on your first try? Absolutely not. Is there different ways to do this? Absolutely. Something even maybe smarter is simplify your inside first and then apply this. So maybe try that out on your own. Try and simplify the inside and then square root it. That's good practice because the answer should be the exact same thing. Okay. we're going to now do our very last example of this unit. Okay, so this is a word problem. Example 3. A cone with a height and radius equal has a volume 20 centimeters cubed. What are the radius and height of the cone to the nearest tenth? So in this case, we should probably draw a diagram. Okay, so we're talking about a cone. So a cone looks something like this. And our cone is saying that our height and our radius are equal. So this thing has a radius, r, and a height, h. R equals h, they're the same thing. So I'm just going to represent that as x. Okay, we have the volume of this. The volume of this cone is 20 centimeters cubed. Now, this is not something you'd have to memorize. You have a formula sheet, and on our formula sheet, we have the volume of a cone. Okay, the volume of a cone is pi r squared h over 3. Now, it wants us to figure out the radius and height of the cone. We'll recognize our radius and our height are the same thing. Okay, they both equal x. So here, I can represent r with an x and h with an x. So this will be pi x squared times x over 3. So I've replaced my h with my x and my r with my x. And now from there, I can simplify. So I have two similar bases, and I'm going to add their exponents. So remember, this has an exponent of 1. So this will be pi over 3 times x 2 plus 1 to the power of 2 plus 1. So I can represent that as pi over 3 times x cubed. And now from there, we can solve this because our volume equals pi over 3 x cubed. My volume is 20 centimeters cubed, and that equals pi over 3 x cubed. And from here, you're simply solving for x. So the first thing I'm going to do is I'm going to multiply both sides by 3. Okay, so 3 times 20, that gives me 60. And these cancel out, so I'm left with pi x cubed. Now I got to divide pi from both sides. I'm going to take out my calculator here and do 60 dividing pi, and that gives me 19.0985 centimeters cubed. And then finally, how do I deal with that cube? I'm going to cube root both sides. Okay, and by this point, you know how to plug that in your calculator. I'm actually going to plug it in my calculator using an exponent. So this is 19.0985 to the power of 1 over 3. So I'm going to take my answer in my calculator. Okay, so remember, to get the answer you just had, you press second ants to the power of 1 dividing 3. So that equals 2.67 centimeters. I could have also plugged this into my calculator. Remember, you press math 4 to get a cube root, and you could plug in 19.80898599317, and you'll get the same solution. Okay, so we get the same thing doing just in a different method. One I'm using radicals, the other one I'm using exponents. But either way, that's how to do a problem like that. So I would suggest really going and practicing and checking your understanding with AFL 4.6. Have a good day.